Today we'd like to go through an overview and demonstration of a Palo Alto Networks next generation firewall. Our agenda for today, a brief PowerPoint presentation that will last roughly 10 minutes, discussing the problem we solve, our underlying technology, and some examples of where we fit. The product demonstration will use the management interface to show you visibility into the applications, users, and content on your network, how you can translate that information into policy-based control, and then validate, investigate, and respond using the log viewer and the reporting components of the product. The problem we solve, applications changed, firewalls didn't. When you think about what a firewall is designed to do, it's designed to be the traffic access control point for your network. You build policies based on what you want to allow. Everything else is implicitly denied. That's also known as a positive security model. Now, unfortunately, applications have changed such that those policies are less effective than they used to. Some examples: antivirus vendors using port 80 to deliver updates to your desktops. This began back in 1998. AOL instant messaging, asking your users if they can find, if it needs to find an open port. SharePoint, also using similar techniques, but it's a business-focused applications. Peer-to-peer, file sharing, all the other instant messaging applications use similar tactics to try and evade controls, not to deliver malware onto your network or to steal data, but to make it easier for your users to access the applications. Another great example that is very business-oriented, Microsoft Link. It's the communications mechanisms for Microsoft Office 365. It requires you to open port 443, port 3478, port 5223, and then a range of ports between 20,000 and 45,000, as well as between 50,000 and 59,999. That's a great example of how difficult it would be to manage one of today's more modern applications with a port-based firewall. The ramifications of the evolution of the application landscape are as follows. Applications are a threat vector. They can deliver malware, obviously. We know that. They're a threat target. SQL injection attacks targeting your business applications is a great example. And then applications act as command and control for exfiltration of their payload. So it's very critical that organizations regain control over the applications, users, and content on the network at the firewall, as opposed to trying to do so with a mishmash or a mix of other disparate technologies. Here's how we believe your firewall policies should be built. They should be built based on applications, users, and content. Your business runs on these three components. We believe your firewall should better support those business initiatives at the policy level. We begin that process with AppID. AppID classifies all traffic across all ports first and foremost. What I mean by that is that as soon as traffic hits our firewall, we begin looking to see what the application is. We look across all ports using heuristics, application decoders, protocol decoders, SSL decryption, and signatures, and we identify the application, and that becomes the basis for your policy. So instead of allowing port 80, now you're allowing the specific application, such as Oracle or Gmail or Box.net, and we tie that information then to users, integrating with Active Directory, LDAP, eDirectory, a range of other terminal services solutions, as well as Microsoft Exchange. And finally, an API gives you the ability to tie into Juniper or UAC environments or even Cisco NAC environments. Global Protect extends the policy control that you might have at corporate level out to any device. So the same policies that protect users within the four walls of your office, are protecting the users when they're out using their iPad, their iPhone, their Android device to access the network. The policies are consistent. You can also set policies based on device status. Things like disk encryption, personal firewall, antivirus updates, all can be built into the policy at the firewall level. So it's a very powerful, very consistent set of policy controls that you have over the traffic on your network, regardless of the user location. And then the content is protected with Content ID and Wildfire, providing you with full IPS protection based on the specific application, not the port. And Wildfire gives you the ability to protect the network from unknown malware or APTs within as little time as an hour. Again, protecting the users, the content, and the applications traversing your network. Here are some examples of our 5 technologies in action. At the top level here, you'll see Oracle, a database application. This might be a data center application example where in the data center we are validating the applications, we're validating the users, we're segmenting the network, you're segmenting and protecting the credit card information, and then you're scanning it for high-speed threat prevention. It's very different than a perimeter example where you're protecting all the users from the range of applications and related threats that they might have access to on the internet. The middle use case here is WebEx. You're allowing the sales team to use WebEx, and you might be blocking them from using WebEx desktop sharing. So you're striking a balance between allowing a particular application and controlling or denying the use of a particular application function. In the middle section, SharePoint is being used by an authorized user, such as the marketing department, and you might be not allowing the marketing department to use SharePoint admin. Only the IT department would use SharePoint admin. And then finally, you're scanning Gmail traffic for threats, and you're blocking the transfer of file types within the organization for a particular set of users. Some great examples here of how you can tie applications, users, and content into a single unified policy based on the firewall. When we look at the core features outside of the 5 technologies that we talked about just a minute ago, these are the components that you need to integrate into your network seamlessly and easily. Strong networking foundation allows you to tie into virtually any networking environment. Management, high availability are all standard features, as are the site-to-site VPN, remote access VPN, and bandwidth shaping or quality of service. These are the core features that allow us to tie into your network seamlessly and easily. Where we fit, we talked a little bit about this already. At the perimeter, you're protecting the users from the big bad internet. You're looking across all applications, all ports all the time, and we're protecting against threats. When we move into the data center, it's about segmentation, isolation, and validation. So you're segmenting the network using the zone-based architecture, isolating the credit card information or the database information behind a security zone, but you're doing it based on application and user, not port. You're looking for rogue or misconfigured applications. You're looking for users who might be accessing the data center with SSH or with TeamViewer or with RDP. These are users who shouldn't be using these applications in your data center. And then finally, you're preventing threats with high-speed threat prevention in the data center. As we extend out to the distributed enterprise, it's consistency in policy control at the branch offices, the remote users. It's the same policy that you might have at the corporate headquarters, regardless of location. That wraps up our brief discussion of the solution that we provide. Now I want to jump into the product demonstration. That will take roughly 20 minutes, touching on visibility, policy-based control, using the visibility that you just gained, and then validating, investigating, and reporting on the traffic incidents on your network. Thanks very much for your time. I'm going to jump into the demonstration now. Be back with you in just a second. Now let's take a look at the device user interface for a Palo Alto Networks next generation firewall. When we log in, the first thing that you'll see is the dashboard. Dashboard tells you the status of the device, the status of software, who's logged in, so on and so forth. Where most of the security administrators would spend their time is in the ACC or Application Command Center, the Monitor tab, where the log viewer is, and Policy tab. Let's first start with ACC. ACC gives you a 10,000-foot view of the traffic traversing your network. And when I say the 10,000-foot view, I do so purposely in order to differentiate it from the Monitor tab. The Monitor tab we'll talk about in just a moment. That's where the log viewer is. That's where you do the ground level forensics analysis when you have a security incident on your network. ACC gives you the visibility into the traffic on your network, who's using the applications, and the types of content traversing your network. So let's take a look at what ACC gives you in more detail. So you can change the time frames that ACC is analyzing. You can change how it's sorted. Right now it's based on sessions, but you can change the sort criteria based on bytes or threats. And you can change the number of entries in each one of the individual boxes. We're going to leave it as it is for now. On the right-hand side over here, you see the security risk level. This is an assessment of the traffic traversing your network based on the application risk factors that you see here. So you see that it's a 3.7. 5 is a high risk. Low risk is rated as a number 1. So we'll get into how that is calculated in just a moment. What you see at the top of the list here is applications. When you scroll down further, you'll see the URL categories that we show you. Scrolling a little bit further down, you can see the threats traversing the network. Again, the threat prevention engine incorporates IPS protection against vulnerabilities. It incorporates virus protection, spyware protection, and other types of malware, all into a single unified signature format scanning engine. So you get a sense for the applications, URL categories, threats, and the data patterns and file types traversing your network here in the data filtering page. Now, let's scroll back up to the top here for a second. Now, imagine for a moment that you've come into work as an administrator and you see BitTorrent on your network. You might not ever have seen BitTorrent before. It's a new application, and you want to learn a little bit more about it. BitTorrent, you drill down into the second level of ACC, looking specifically at BitTorrent. The first thing that you see for every single application, this is on device, the database on device for the applications. You see the description of the application. You see the different ports it's using. And then you see the answers to a series of criteria, yes-no questions, if you will, for how the application operates. Can it transfer files? Has it been used by malware? Does it consume bandwidth? Does it tunnel applications? So on and so forth. So there are 8 questions that we answer for every single application. And that's how we come up with the risk factor of 5. Every one of these is a yes, so it's going to be a 5. We have some customers who want to modify the risk level. You can do that very easily. So if you use BitTorrent, for example, to get Linux binaries, and you want to assign a risk level of 3 because only a select group of users are accessing BitTorrent, you can do so. In the span of just a few minutes, we've given you a little bit of information about what the application is, and we've given you a significant amount of information about how the application operates, the ports it uses, and the characteristics that it uses. So in that small amount of time, you've now learned more about how the application operates and you can make a risk assessment based on that information. Scrolling further down, you see the user information. Again, this is the information of who's using the application, and this is where you start seeing the impact of user ID. User ID integrates with the user directories on your network. It might be Active Directory, might be Exchange, LDAP, so on and so forth. But this is where we tie the application use to the user in terms of specific user identity. If you're not using user ID, you would still have the IP address information. Scrolling further down, you see the destination for of the traffic in terms of specific users. You also see the source countries, where the traffic's coming from, where the traffic's going to. And then you'll also see at the very bottom of the page here the security rules the traffic is touching, and the security zones, the inbound and outbound security zones that the traffic is traversing. So again, thinking about the visibility into your network, what ACC gives you is more knowledge about what's happening on your network in terms of applications, users, and content. As you see up here in the upper right-hand corner of your screen, there's some little icons. These are all icons that will jump directly to the log viewer in the Monitor tab. And you can see that there is a traffic log, a threat log, the URL filtering log, the data filtering log, and finally the host information profile log, which is part of Global Protect. So if we saw something in ACC here that needed further, more granular investigation, we can jump to the log filters, and all of this criteria, the BitTorrent traffic for the last hour based on sessions, would be carried into the log viewer. Let's stick around in ACC for just a moment and take a look at an individual user. So Steven Sharma here appeared to be using a fair amount of BitTorrent. So we can drill down into Steve Sharma's traffic for BitTorrent, and we can analyze that a bit further. But I want to know what other types of applications Steve Sharma is using. Is he just using BitTorrent a single time? Or is he using other applications that pose certain risks for my network? So by removing the BitTorrent filter, I now see all of the applications here at the top of the screen for this particular user. I see that he is using BitTorrent, and then he's using a series of other social media applications, some music applications, and some Google applications. So I get a sense for the type of traffic this user is experiencing on the network. Again, in the same manner as the top-level ACC, we get to look at the source, the destination, user IP addresses and countries, and also the security rules and the security zones that this traffic is touching. So again, reminding you as to what ACC gives you, it is on-box visibility into the traffic on your network based on applications, users, and content. Now let's jump into the policy tab for a moment. Take a look at how we would build a security policy to enable applications, users, and content. Here you see the basic policy tab. On the left-hand side, you see where we would set policies for SSL decryption and SSH control, as well as policy-based forwarding and application override. We're going to stay in the basic policy tab for just a moment. As you can see, we've got the different zones. It's a zone-based architecture, allowing you to build logical containers for IP addresses, user interfaces, and VLANs so that you can build very flexible security policies. Where we begin to differentiate ourselves from many of the other firewall administrative user interfaces is in the user column and the application column, and then in the profiles column. So these are where you build policy based on applications, users, and content. Let's take a look at an individual application rule for a moment. We're going to look at remote management applications. So I want to modify the users who are able to access the remote access applications here. So we're integrated with Active Directory here. I can add groups by clicking on the add, and I can add the help service group. I notice that they're already added, so I'm going to delete that and add a different group. Let's add the user database. So we'll add that, and then we'll remove the help services group. So we're going to say, and then if you wanted to add an individual user, you would do so just by typing ahead. And we can add Rachel Johnson to the list there. So we've quickly added a series of groups and users to the user group. When we scroll further over here to the application tab, there are 3 ways in which I can add applications to an individual rule. As you see here, they are added individually to the list. So that is the first and very commonly used mechanism. There are 2 other ways we can add applications. As you can see, we categorize our database of applications based on category, subcategory, technology, risk, and characteristic. So I can build policies based on those characteristics using filters. And this is the second way in which I can add a policy. So a filter is a dynamic list of applications. And what we mean by dynamic is that when we build a policy for peer-to-peer file sharing, for example, it is going to use file sharing as the category and peer-to-peer as the technology as 2 of the main filters. So when we build the application filter for peer-to-peer technologies, that list of applications is roughly 50 applications. Now, later this week, when we deliver the content update, that we might add a 51st application to the list that fits this criteria. So all you would need to do to make sure that your policy is updated is update the content on your device. So when we deliver that application in the new database of applications, you update your device, this policy is automatically updated. You don't have to manually touch every policy that has a dynamic filter as the application criteria for your policy. So that's a very powerful way to build application policies using a filter. An application group is a little bit different in that an application group is a static list of applications. So a good use case for an application group might be using remote access tools and allowing only the IT group to use a select group of remote access tools. One of the things that we find is that non-IT users are accessing things like TeamViewer and RDP to go through to the firewall and out to their home machines and do things that are non-work related. So by limiting the use of remote access tools to only the IT group, so for example, you would select SSH, Telnet, VNC, RDP perhaps as your select group of remote access tools, and build an application group and apply that only to the IT team. Then you deny all usage for all other users. You're now reigning in control of the remote access tools using an application group. So there are 3 ways, as I mentioned, to build a application policy. There's the individual applications, a dynamic filter, and an application group. So one of the best practices that we really strongly recommend is using the application default as the service when you're allowing applications, and using any when you're denying applications. So what this does is this makes sure that this forces this set of applications to use what would be considered to be the standard port. If it tries to hop ports, we will recognize it and force it over the application default port. When we look down at some of the applications that are blocked, up here, for example, we're going to apply the service to look for the applications in these groups in this category across any port, so that when it begins hopping ports or looking for ports in the high range of ports, say in the 60,000 range, we will see that application even if its standard port is something else, and we will block that application. So to summarize in terms of best practices, we would use any when we want to block applications. We would use application default when we want to allow applications. Getting back to the policy for remote management applications here, what we want to do now is take a look at profiles. Profiles allow us to set the very specific threat prevention profiles for this particular type of traffic. So what we can do is we can pick and choose the different types of profiles for each one of the application rules. So we're going to set antivirus profiles, for example. We can block all the viruses traversing this type of traffic, or we can go in and we can create a very granular, very specific profile for antivirus protection. Right now we're going to select default. We're going to then also go in and take a look at vulnerability protection. So you can, again, if this were an SQL traffic, you could apply SQL injection attack protection against this particular Oracle database traffic. So you can get very specific with the different types of profiles. And then you kind of scroll down further on down the list, and you can see the different types of security profiles we can apply to this one particular rule. And we're going to set those two profiles up, and we're going to click OK. So if we go back to the premise that Palo Alto Networks presents to you in terms of your security policies, we talked about being able to enable applications based on users and content. And that's what we mean when we talk about a unified policy. Is we've just built a single policy for remote management applications. We're allowing it for a particular group of users. We've set the list of applications here, and then we've applied a very granular, very specific set of threat prevention profiles to that traffic. So we're giving you the ability to enable applications on your network, and in doing so, help you enable your business. Now let's spend just a moment in the Monitor tab. Monitor tab is where we would find logging and reporting capabilities. This is where you do the granular forensics, the investigation into the traffic traversing your network. We talked about ACC earlier, giving you the 10,000-foot view. The Monitor tab is the ground level view. All of the logs that you see here are exportable or can be sent to a syslog server for analysis by folks like Q1 Labs, ArcSight, and so forth. If you visit our public website and you go to the partner section, you'll see the technology partners, and you'll see the full list of all the different SIM vendors and log analysis vendors that we've integrated with. It's quite an extensive list. But what you can do here is you can drill down into each one of the elements here. You see that we have the source information, the user information, as well as the port that it's traversing. So you can quickly build a policy, for example, for SSL traffic, and I can expand into the traffic that looks for SSL traffic over a period of time. For example, in the last 60 seconds. So I've added that, as you see there, and then I can generate that log view fairly quickly, and you get a sense for all of the SSL traffic traversing the network. So you would be able to build that type of a query very quickly, very rapidly, in order to do that ground level forensic analysis. The reporting, there are roughly 50 or so predefined reports that are available on the device. All of the reports can be mixed and matched and combined and customized and then saved and used at a later date, run at a particular schedule. They can be exported to PDF, CSV, or common delimited file, or XML. They can also be emailed to a particular user group of individuals. So very powerful predefined reports that can be customized and used to address any particular reporting need. And remember that the logging and the reporting are standard features that are on box. They are not being run on an individual device or off box. They don't require a secondary box. that wraps up our demo for today. I really appreciate the time you've taken to learn more about Palo Alto Networks. If you have any questions, please take a moment and drop a note to your local Palo Alto Networks sales representative or channel partner. Thanks very much.